When a yo-yo is released from your hand, gravity acts on its center mass, pulling it downwards. Since the string is wrapped around the axle of the yo-yo and the other end is attached to your finger, it is forced to rotate as it descends. The spinning yo-yo converts gravitational potential energy into angular momentum, otherwise known as rotational kinetic energy. When the yo-yo reaches the full extension of the string, it continues to spin at the bottom, since the string is usually tied loosely around the axle. In this condition, there is no more room to drop lower, thus, no more increase in rotation. The friction between the axle and string will eventually dissipate the energy, causing it to come to a stop. A tug on the string causes the kinetic friction between the string and the axle to increase momentarily. At this point, the axle stops slipping, and the angular momentum of the yo-yo is sufficient enough to rewind the string upwards. This is when the yo-yo converts the rotational kinetic energy back to gravitational potential energy until reaching the stopping point, or your hand. The following graph is the theoretical velocity and position versus time trends for the yo-yo, which was the basis for this video. We looked at the visual mechanics of how the yo-yo goes through this motion and measured its velocity and position over time using an iPhone app called Video Physics. As you can see, the yo-yo is able to be dropped or propelled downwards with a momentary stop at the bottom before being tugged upwards and rewinding. The yo-yo, due to technique, is being propelled downwards, which results in an increase in y velocity, then a sharp decrease to zero velocity when it reaches the full length of the string. After a tug is given, the yo-yo begins to rewind and the velocity increases upwards, and then decreases until reaching the stopping point.